other the same way that transistors do in a circuit. And so essentially what we do is to test the cells to find out, when we give them computer-generated signals of all possible signals, we give them random signals and we ask, how do they behave? And by looking at the translation, we figure out what the function is, and we can describe that function with a set of mathematical equations.
This portion is similar to one neuron.
My colleagues have taken that mathematical model and built a microchip circuit, very small, millimeter by a millimeter. So we can take a part of the hippocampus that's a circuit, we can cut out parts of it, throw it away, and we replace it with the microchip. And so now the whole circuit works just like the biological circuit, so that incoming information looks like, incoming temporal patterns look like outgoing temporal patterns, just like it does for the biological piece of tissue. But now there's a microchip in there, instead of having biology in there.
The chip is presently being tested on animals. One problem that remains is how to connect the chip to the brain. Today's technology uses tiny electrodes, but in the future, another option might be to put some brain cells directly onto the connection points of the chip. They would then be guided to form connections at exact points within the brain in order to establish the perfect interface.
Ça pourra permettre de réparer des cerveaux endommagés à la suite d'accidents, de blessures, n'importe quoi, de maladies. Mais d'un autre côté, ça permettra aussi de faire une communication peut-être directe de cerveau à cerveau. Des choses qui sont effectivement pour l'instant limitées, la communication intra-humaine étant limitée avec la parole, alors que là, l'idée qu'on peut directement peut-être communiquer des expériences globales de cerveau à cerveau, c'est quand même quelque chose de fabuleux qu'on peut rêver. Et puis bon, il y a des tas d'autres applications peut-être plus pratiques à court terme.
One such concrete application has already been realized. The chip is used to recognize sounds, since it can literally do that with the same accuracy as we do.
So we've used these brain-based models as to develop acoustic recognizers. So we train them in the same way that your brain learns to recognize a particular sound. And one of the first sounds that we've developed is one for gunshot recognition. It's a model of how hippocampal neurons communicate with one another. That's all it is, biology.
You got one over there across the park, then they have another one they used to have right there. Then they just put up another one over here 2 days ago. These high-tech cameras, they are called Crime Stoppers. If a gunshot goes off to my left or to my right, the camera automatically traces down the sound of the gunfire and zooms in and takes pictures.
You cannot buy a system today that can recognize speech signals or any other signal in noisy environments. They don't work. But your brain works that way, and because our model is based on the brain, our models work in noisy environments.
And the thing is, there are no cameras installed in the white neighborhood, but we have 5, 6 cameras in the black neighborhood. So the black neighborhood is being watched.
If an airline pilot is about to press the wrong button, it may be important enough to think about trying to identify what the patterns of thought are, what the memory patterns are, and if the person is recalling pressing the button so that we eject when they're not supposed to, or press the button so that a bomb goes off and they're not supposed to, then you might want to intervene and prevent that. I'm part of another project that is funded by DARPA that's trying to understand exactly that. I mean, how is information represented in the brain?
And science is supposed to have all the answers. But this has got to work.
It's not going to fail, not after we've come this far. We have here, for all practical purposes, a normal human being, except for his electronic sensory control system, of course.
On devrait, avec des localisations donc de ces circuits électroniques dans différents endroits du cerveau, de pouvoir lire le contenu du cerveau et le mettre sur un disque dur, le transmettre directement sur à une autre personne, etc., etc.
Part of our problem is in getting enough sensors into the brain without destroying it, getting enough sensors in there so that we can extract enough information to infer what the total pattern of activity is. And if we can do that, then we have to develop a mathematical model of how information along all those pathways develops and is processed. And so for the next few years, that's going to be the task. Now, if we can do that, then we'll get to the finish line. We will get to the finish line.
It's a conservative statement to say that by 2025 we'll be able to look inside your brain, see everything that's going on, all the interneuronal connections, all the synaptic clefts, all the neurotransmitter strings, and create a huge database and copy down every salient detail, and then reinstantiate that information in a neural computer of sufficient capacity and create basically a copy of the thinking process that takes place in your brain. Now that's one scenario, but it's really an existence proof to show that we can tap the secrets of intelligence that exist in, let's say, the human brain. Once we've scanned that information, we can also understand it, see how it's organized, improve on it. We can extend it. We can make the memory 1,000 times bigger. We can make it faster. We can expand the perceptual capabilities.
To transfer your mind to a computer, this seems to be the ultimate dream of many scientists. To liberate us from our old body that is becoming obsolete in this technological world. We would then go on living as free spirits in cyberspace.
I'm not interested in a future where there are post-human beings if I'm not one of them. I want to be there. It's very important to me that I live and thrive in the future, not just to think about some robots taking off into space. I want to be there.
So in a way, mind uploading is a shortcut around artificial intelligence that will allow us to have machines with human minds.
I'm hoping that we could fit on a CD-ROM. That's 600 megabytes. And I'll bet that that's all you need to copy a person.
So it's a difficult time to predict what these new humans will be like. I think it's